Good day, and welcome to CFE Media's Virtual Training Week. For this session on the market for predictive maintenance in motor-driven systems, we'll be joined by Blake Griffin, a senior analyst with Interact Analysis. I'm Kevin Parker, an editor with CFE Media and Technology. Following our presentation, be sure and stay tuned for a live Q&A on Zoom that will begin at 12:45 p.m. Central Time. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. This virtual class session is designed for technicians, engineers, and managers who want to better understand how computerization advances make possible the use of predictive maintenance to improve productivity and reliability of manufacturing assets. This webinar will focus on the markets, opportunities, issues, and technologies involved. You see before you the learning objectives of today's session, focusing on models and sensors and integration. You see before you some tips to help you get the most from today's event. Attendees are eligible for one PDH credit for this event airing on October 7th, 2020, and is categorized within the technical, health, and safety categories for RECEP. This event is a live educational session presented on October 7th, 2020, and on demand afterwards. I'd now like to introduce today's speaker, Blake Griffin, Senior Analyst, Interact Analysis. Blake has worked as an analyst at Interact Analysis since 2017, covering the markets for low-voltage AC motor drives and predictive maintenance. Blake has developed a comprehensive understanding of the drivers of and barriers to predictive maintenance technology across manufacturing. Thanks, Blake, for joining us today. The floor is yours.
Thanks, Kevin, for that introduction. I really appreciate the kind words. My name is Blake Griffin. I'm a senior analyst at a company called Interact Analysis. And I think the thing I want to get out of the air first is that I am not an engineer. I cover markets, and my job as an analyst is to take markets that are very complex in nature and boil them down to a way that's digestible for people who are less familiar with this technology or the market to enter and understand the trends and the technologies involved. So my goal with this presentation is less to talk about the technical aspects of the technology that is used within predictive maintenance. It's more to provide context for all the other presentations that you'll see today and try and give you a perspective of where we believe trends in predictive maintenance are going, some of the technologies that we think are going to be winners in this area, and then some business models that are emerging that we believe are enablers of predictive maintenance. My co-author on this report was a man named Adrian Lloyd. He's our CEO and research director. And I'll introduce him as well as some of the other leaders of this business a little bit further on. Before I get into predictive maintenance in the market, I think it's helpful if I go through exactly what Interact Analysis does. I think it's helpful if you understand where I'm coming from as an analyst and just providing context a bit about what we cover as a company. We cover intelligent automation, and a quick way to explain what intelligent automation is by looking at this slide. These are the four areas that we cover. Industrial automation is the area I generally sit in. As Kevin said, I focus on markets like low voltage AC motor drives, as well as predictive maintenance. Predictive maintenance has been the topic that I've been having conversations about for a little over a year and a half. My day-to-day in this area is really centered around interviewing people like yourself. So I interview engineering managers, I interview product managers and marketing managers, and it's all in an effort to build up my own expertise on this market, trying to get as many perspectives as possible and boil them down into a digestible format. The other areas of coverage that I don't play in as much, but it's still worth pointing out to give you some context, is robotics, warehouse automation in commercial vehicles. Robotics dealing with collaborative robots, industrial robots, mobile robots, things like that. Warehouse automation, so looking at automated storage and retrieval systems. And then lastly, commercial vehicles. And this is dealing with both the electrification of vehicles, but also vehicles that are going autonomous, some of the happenings in the off-highway space, things like that. This is a quick list of the reports that we've published so far. I think probably the most important for this particular presentation is the top left corner. It gives you a little bit of context into what we cover in our expertise in manufacturing. As I said, I've dealt with low voltage AC motor drives and predictive maintenance. The two definitely overlap pretty heavily, and we'll get into exactly how they overlap, but those are the two areas that I primarily focus in. This is the leadership team for Interact Analysis. As I said, Adrian Lloyd is a co-author on this report. He works with me in the Austin office. He's very knowledgeable. He's had over 20 years experience being an analyst in industrial automation and covers motor drives along with me. Ash Sharma heads up our robotics division. You may have seen him give a presentation at a conference if you've attended one in the last couple years dealing with robotics. He often speaks and gives webinars. Tim Dawson is in the industrial automation as well, along with Jan Zhang, who heads up our China office. And lastly, Alistair Hayfield is the head of the commercial vehicle department. All of these guys are absolutely brilliant analysts. They started this company to really get back to doing primary research in all of these markets that we've covered. I can't speak highly enough about each of them. Before we get into the trends, I'd like to give an outline for exactly what we covered in this research. One of the things that we wanted to do early on is define an area of predictive maintenance that's actionable enough so we can actually go and find good solid data that will be informative and less broad in nature. Because predictive maintenance is such a huge topic, we really tried to find like an application for which this will be both broad and applicable so you can actually get some good data out of it. What we landed on was predictive maintenance in motor-driven systems. And when we say motor-driven system, we're talking about low voltage motors, so AC induction motors, fans, pumps, compressors, bearing blocks, geared units, that kind of stuff. That's the scope of the predictive maintenance that we're covering today. And these are some of the products that we're focusing on and that we focus on throughout the research. I'll go in and define each of these in the next slide, but the one that I want to point out because it features so heavily in this presentation is smart sensors. Smart sensors are, the way I define smart sensors are wireless sensors that can be attached to motors that provide you some level of data on the health of your asset. The main differentiator here between smart sensors and traditional sensors is their wireless capability and the fact that they have an ability to do some level of computation on the device itself. The other thing I want to point out is the reason we're calling them dedicated gateways, dedicated software, dedicated services. That's not initially clear, but the reason that we decided to do that was because if we were to include general purpose gateways, general purpose software, general purpose services, it would bloat the true market size and the opportunity that's available within this market. So we call them dedicated software and dedicated gateways. These are the software and devices that are sold alongside like a smart sensor solution, or they're explicitly sold as a solution for predictive maintenance. So things like Tableau, for instance, can be used theoretically for predictive maintenance. It has that analytical capability. However, that wouldn't be included in the revenues that we're presenting because it's more of a general purpose and it would bloat the overall size of the market. I'm not going to talk too much about the further product segmentations. This is how we broke them out in a little bit greater detail, but it doesn't feature very heavily in this report. So I'm going to skip over this a bit. The last part of the report that we did was doing an installed base analysis. And the reason we wanted to do this is because if you're able to understand the number of motors, fans, pumps, compressors, bearing blocks, geared units that are installed globally, you have a picture for the opportunity for predictive maintenance. So it's very important to us that we come up with a number and say, this is actually the opportunity. if we can understand, what motors are demanding this technology the most, you can start getting a feeling for the opportunity that's out there for these products. And what we learned pretty quickly was that this technology is not penetrated hardly at all within motors. We're talking less than 0.1% of the number of installed motors globally actually have a smart sensor or some type of sensing connected to it. And it is growing, but as of now, it is very, very limited. And we'll get into that a bit more. As I said, I wanted to define these out a little bit more. The two I really want to focus on, again, smart sensors. I'll reiterate, they are wireless and they have a level of computability on them, on the device itself. That's what differentiates them from traditional sensors, which are more the wired solutions that have been around in industry, especially in process industries, for a very long time. Portable measurement devices is the other one I want to point out. Throughout this report, they're referred to as portable measurement devices or portable monitoring devices. They're the same thing, but they are the handheld vibration monitoring devices that companies like Fluke provide. A lot of maintenance technicians are very familiar with this. Basically, you do rounds around your maintenance facility and you're taking readings on vibration and temperature and things like that. That is what these portable measurement devices represent. They're really the status quo of predictive maintenance right now. They're the most common device used. And we'll get into exactly their relationship with smart sensors in a bit. So it's a good way to start unpacking this idea of predictive maintenance is to look at exactly what options you have for maintenance currently. In my research, I interviewed probably 40 to 50 different people for this report, and I identified these 4 maintenance strategies. The first one is not really a strategy as much as it is a lack of strategy. It's a run-to-fail method. This is basically not doing anything. You install a motor, and when it breaks, you replace it. It's not very sophisticated. It's not sophisticated at all, but it can be a viable option if you're having a motor or a piece of equipment that's in like a non-critical application, or it's a really cheap motor and you have an excess amount of replacements. We don't recommend this, obviously, but it does have its place in some facilities where it just doesn't warrant spending the extra time and money on maintaining. Reactive maintenance is the second one. So it's moving a little bit more into more sophisticated areas. Reactive is a term I coined because I wanted to get away from calling it preventative maintenance, but fundamentally it's the same thing. The reason I wanted to get away from preventative is that when you talk preventative and predictive, the terms get conflated really, really often. So any way to kind of separate the terms I thought was going to be useful in explaining how this works. Basically, this is doing the bare minimum. This is following the manufacturer's guidelines on how often to change the oil on a motor, how often to realign it, things like that. But by and large, it's not a very sophisticated method, and you're still reacting whenever things go down. You're not trying to predict when they're going to fail. Condition monitoring is where it starts to utilize more the technology that we outlined in the previous slides. This is still not totally predictive maintenance, although a lot of people think that they're doing predictive maintenance when they're employing this type of strategy. It's using those portable monitoring devices and sensors to understand what state their asset is in currently, but it's not utilizing or putting forth any effort to actually predict when that asset is going to fail. That's the key differentiator between condition monitoring and predictive maintenance. Predictive maintenance is actually putting a timestamp saying this is how long we have until we need to address this issue, whereas condition monitoring is really just saying this motor is starting to behave a little bit differently. It doesn't put that timestamp on it. The two are kind of blurred a bit, but that timestamp is the key differentiator. This is the spectrum of maintenance strategy if you were to put it on a line of sophistication. On the very far left, obviously, is run to fail. I think it's pretty self-explanatory why it's on the far left. As it moves into a little bit more sophisticated strategy, you have reactive maintenance or preventative maintenance. You start getting it like where I think most companies are between this reactive and condition monitoring stage, where they have kind of a robust scheduled maintenance program and they're doing a little bit of condition monitoring, maybe doing some route-based monitoring. So having a maintenance technician walk your facility and take readings of your asset. That's kind of where most of the market is right now. As you get into a little bit more sophisticated strategy, you start having remote monitoring capability. So the ability to actually look at a device's health from an area outside of your manufacturing facility. And you start using that with a historian, that's when you start getting into the predictive side of things. The physics of failure is a term that's used pretty commonly by smart sensor companies. This is the idea that certain motors and certain applications that are well understood behave a certain way, and it's a very well understood behavior. So if you're taking vibration readings on a motor, there's a profile that is within normality for very well understood applications. It's still relatively unsophisticated when you're talking about a predictive maintenance method, because in non-well understood applications, this doesn't really work. And most of the applications that are going to need predictive maintenance are what I would term at the moment not well understood from a vibration analytics perspective and from that perspective. So it's a good strategy. It's more sophisticated than most, but it's not the most sophisticated when you talk about predictive maintenance. The reason that I have parameterization by a skilled maintenance tech here on the right as being more sophisticated is that a lot of these skilled maintenance techs who have experience in these non-well understood applications know the behavior of how these motors and how these assets are supposed to perform. This automatically takes you into like a more sophisticated area if you have someone that's skilled with the knowledge and expertise on knowing exactly when these motors are going to fail and being able to predict out as much time as you have. And that's why I consider it slightly more sophisticated than physics of failure. And then the most sophisticated, and this is something that's continuing to evolve, is using artificial intelligence and machine learning algorithms. Fundamentally, this is data in, probabilities out. The more data that you have to offer your machine learning algorithm, the more accurate it becomes. There is a level of training the algorithm that goes along with this, but this is continuously the way the direction the market is moving. And I have it sort of an arrow going to the right because it's still evolving. Predictive, I don't think, is going to be the end-all solution. People are already talking about prescriptive maintenance, which is not only describing when the motor is going to fail, but what you need to do to address it. That's going to be kind of the next evolution, but we're a bit of a ways off from that right now. Another thing I'd like to point out about this axis is that of the companies I've spoken with, you would think that some of the larger companies would fall more on the right side of this spectrum. And really that's not the case. It's kind of all over the place. A lot of multi-billion-dollar companies that I've spoken with aren't doing any predictive maintenance, whereas a small operation with 50 staff or whatever might be investing heavily into this technology as a way to be more competitive. It's really all over the place right now. You really don't have any sort of indication on which types of companies are employing this right now. Getting into the value proposition of why predictive maintenance is very valuable to look into as a technology, there's really two main propositions that people point out, and everything kind of falls beneath these. It's risk avoidance and optimization. When you talk risk avoidance, the number one value that predictive maintenance brings is its ability to mitigate your risk of downtime, and that helps reduce production loss. This is the number one thing that every single smart sensor producer or anyone involved in predictive maintenance constantly touts, is the ability to reduce your risk of downtime. It's something that we all strive to reduce. This technology is really hitting at that. There's a safety component to it as well. In the event that you have an application where the motor is in a very unsafe area, any way that you can mitigate the amount of time that you have to spend actually performing maintenance on that motor is worthwhile and can help mitigate any sort of costs that would occur if you were to have a safety incident. So putting a smart sensor on a motor basically makes it a motor that you don't have to visit as often and take readings, therefore mitigating some of the safety concerns. There's also a logistical component to it, and this is not something that I really considered until I spoke with a company that had experienced this. Basically, if you have a big motor or a big motor system that were to fail, not only do you have your stopping of your line, but you also have a cost associated with getting that motor removed. You have to hire someone, a delivery truck, someone to actually come in there and uninstall it and move it out of there. All of that is costly, and it's still your line is still down during that time. So that's another risk avoidance factor that that predictive maintenance helps solve. The other aspects of this is optimization. And the first is equipment optimization. This is more a value proposition from like the purchaser's standpoint. If you have an extensive data set on all of the different assets installed in your facility, you can start figuring out which ones are more reliable than others. And this is key to kind of optimizing your line. If you see a motor from company X tends to go out of commission or trends a certain direction, in 3 years versus a motor supplier Y that lasts, 50% longer, you're going to start switching out as much equipment as you can for that longer, more reliable supplier. There's also an energy usage optimization component. I'm sure all of you are familiar. If a motor is misaligned whenever it's installed, it tends to demand more energy than perhaps the application requires. So if you're able to sensor those motors up and detect that extra stress on the motor early, you can get in there, correct it, and mitigate the costs of an undue burden on your energy supply. And lastly, an inventory optimization component. So this is in two parts, really. There's an inventory optimization from your replacement part standpoint. So if you know exactly how often your motors are failing, you can really carry a low amount of inventory of replacement parts. And there's also a inventory component from your customer standpoint. So there's certain service level agreements that you're going to have to meet, and if you can mitigate your downtime or your unplanned downtime, you can reduce the amount of times that you miss those service level agreements. I was given an example of someone who was supplying Walmart, and they had a downtime that basically made them miss their service level agreement with Walmart, and Walmart actually, because they have so much bargaining power, fine them like $10,000 per day that they missed that. So it can become very, very costly whenever you experience this downtime, and predictive maintenance technology helps to mitigate that. The other thing that almost every single engineer specifically spoke about, anyone involved at the plant level, was OEE, which is overall equipment effectiveness. I'm sure a lot of you are familiar with this metric, but there's always an inherent need to increase your OEE, meaning the basic percentage that it's running without downtime. If you increase this OEE, it generally increases profitability. And each one of the variables associated with overall equipment effectiveness deals with predictive maintenance. Predictive maintenance directly affects all of these variables. So for instance, in calculating availability, runtime is part of the calculation. It's planned downtime, less unplanned stop time. Predictive maintenance, as I've already said, is one of the key values it brings is mitigating the risk of downtime. So this automatically raises your availability, which will raise your overall OEE. Same thing with calculating performance. Runtime is also a part of this variable, so you get that same thing. And then good count in calculating quality, the number of products produced that meet quality standards. Again, if you can reduce the amount of time your line is down, you're producing more goods. And if you can mitigate any sort of defects that are caused by your machinery by getting that data into your assets, you can also increase the good count. So all of these, there is a predictive maintenance component to it that can help improve your OEE. Getting into a little bit more of the market focus and looking at the tech's drivers and barriers. One of the drivers, obviously, we've talked about this in the last slide, desire to mitigate risk of downtime. Don't have to go over that a whole lot. One of the areas that I was becoming increasingly familiar with was this increased need of connected assets from big automation suppliers. If you look at the landscape of who's supplying smart sensors today, a lot of them overlap with who's supplying your motors and your automation equipment. So ABB, Siemens, WEG, those kind of companies. What I've learned is that they've kind of developed all these solutions around software, services, all aimed at addressing this IIoT need, Industry 4.0, whatever euphemism you want to use. They've all developed these services, but there's been kind of a gap in the market where there is a lack of actual connected assets that you can pull data from. So smart sensors is a big enabler of actually connecting these old assets that aren't currently connected. That's why you're seeing a lot of these automation suppliers developing a solution and pushing it. There's an increased sophistication of machine learning and data management technology. So within machine learning, there's a whole sub-market that's starting to emerge of companies that are developing the tooling necessary to develop these machine learning algorithms. This is something that hasn't really been present in the past, and machine learning algorithm development has kind of been looked at as like a traditional software development play, when it's really quite different according to the conversations that I've had. So having that new tooling emerge is only going to hasten the development and sophistication of these algorithms. This sophistication of data management technology is also a big component. We'll get into it a little bit later in more detail, but basically, if you have all these different data streams coming at you, it's a very currently a very piecemealed solution because everybody's producing their own smart sensor, or you're gathering data from like a PLC or a drive. It's all coming in different forms and it's interpreted on different platforms. What's starting to happen is a kind of tying together of all of that. Certain companies are trying to be the ubiquitous solution, the kind of one-stop shop for taking all those data feeds and putting them in a way that's easily interpretable. Again, all that does is serve to make implementing a predictive maintenance solution easier. There's a desire to prolong the life and large and expensive assets. I don't think I have to go into this one very much, but this will be kind of the low-hanging fruit for predictive maintenance in its early stages. And then the reduced cost of MEMS sensing devices. This is a big one. So smart sensors, by and large, probably 90%, if not more, are MEMS sensing devices, so micro electromechanical systems. They are the same kind of accelerometers that you have in your smartphone, or that are used widely in a lot of consumer goods. Because they've kind of achieved this economy of scale, MEMS sensing that is, through consumer goods, the price of these sensors are coming down dramatically. So much so, I can give an example. I was speaking to someone who had trialed a smart sensor supplier's device about 3 years ago, and they were charging at the time $300 per sensor. Now I can confirm, because I've spoken to this supplier, the price of that solution is only $100 per sensor. So just in 3 years, it's come down almost $200 in cost. That just gives you a perspective of the speed that this stuff is reducing at. A couple of the barriers that are some of the most important. This data access and ownership is a big one. This is basically the fear that opening a door to your operational technology through giving someone access to perform remote monitoring services or something like that will open you up to vulnerabilities for hacking, for instance. The other fear is that there's maybe some secret operational data that you don't want someone else to know. So that's another fear for having remote monitoring capability. You can get around this. It doesn't have to be like a solution that's in the cloud. You can handle all of this on the edge or something like that. But that is a big fear, and basically everyone that I've talked to has cited this as a concern. I do think this barrier is coming down right now, specifically with COVID, because there's been this kind of inherent need to have remote monitoring because people can't be in the plant as often. There's a little bit more comfortability with that technology, and there's less of a concern with hacking and things like that. We'll get into this a little bit later when we get into some of the business models, but this is a big barrier that needs to be overcome in order for this to take off. Access to connectivity is another big one. This is talking about access to the internet, but also physical access. It kind of sounds silly, but there is a plethora of motors out there that are just hard to reach. So this is kind of a barrier, but it's also a bit of a driver in a way, because smart sensors can get into these hard to reach areas and you don't have to actually go physically take readings of them. But this still is a big concern, and the access to the internet is also a big concern. A lot of these plants just don't have the capability to communicate the way that these solutions are designed because of maybe they're in a remote location, or they just don't have great connectivity in their facilities. There's an established status quo of maintenance methods currently, and this is a barrier that's a bit hard to overcome just because of the conservative nature of manufacturing. But also, I mean, if you're running a strategy and it's relatively successful, You're not going to change from what you know unless there's a real strong incentive to. And perhaps what I've showed you with OEE, that might, start opening the eyes and showing the incentive, but it's still fairly difficult to convince management to change over to this stuff without a glaring obvious need. I do think this will come down over time as this kind of proof of concept comes into fruition. But right now we're still in early days. That need for proof of concept I kind of just mentioned, so I don't think I need to go into that very much. It's still perceived as very expensive, but this is rapidly changing. Like I said, it went from $300 to $100 over the course of about 2 years. So this is coming down dramatically in cost. The perception is still there, though, that it's expensive. But again, as this becomes more proven and more widely utilized, I think that'll come down naturally. So looking at the revenues of this market, anytime I'm looking at a new market, which although predictive maintenance has been around for a long time, the technology that we're talking about today, so smart sensors and their related software, is a very new market. I always look for an inflection point because that's kind of an indication that there is a need for data for one thing, because it's expected to grow, but also it's going to be an interesting market to cover because there's a lot to develop. And I really do believe that we are at an inflection point for this market right now. Every company that I talked to that was producing smart sensors were citing revenue growth of double, triple, quadruple year over year. Anytime I see that, that's a signpost that the market is primed to enter kind of an exponential growth phase, which is what's happening. We anticipate this market hitting just under 1 billion by 2024, and it's driven largely by the blue bar that you're seeing, which is smart sensors and the related software, which is the light blue, and the dedicated gateways, which are all kind of correlated. They're all basically part of the same solution, but they're driving the majority of the growth. The gray bar, which is portable monitoring devices, is still growing, although it's kind of hard to tell in this graph. They're growing by about 7 to 10% year over year, and we expect that to continue for reasons that I'll get into in a couple of slides. Again, I wanted to reiterate that smart sensors, wireless MEMS, or piezoelectric sensors that have a level of computability, they are what I would consider a frontline technology. So there's a big kind of question mark on how sophisticated this technology is. And I think the way I look at it is it is a frontline technology. It is the first step in understanding the health of your asset, but it is not the end-all solution, in my opinion. The reason for that is like the resolution that it can actually achieve when you're looking at a vibration pattern. It typically operates from like 10 hertz to a kilohertz. That is useful for understanding kind of for getting a basic view into your assets. But whenever you're trying to actually trend out something and predict in other areas, you need those portable monitoring devices, which tend to have a much higher resolution, going up to 10 kilohertz and above. So that's why I think they're kind of a frontline technology, but they are also an enabling technology for industrial automation suppliers. Like I was discussing earlier, there is a lack of connected assets, and these smart sensors will be that kind of bridge to connecting all of these different components in order to take advantage of all the software and solutions that have been developed over the past couple of years. We've already talked about the cost decreasing as being a barrier of adoption that's being overcome. Battery life is also a crucial barrier that is falling pretty rapidly. There has been an increased level of compute ability on the sensors themselves, so far as to say that there is embedded machine learning starting to happen on these sensors. While they are happening, it's a lot of hand waving right now. It's not really a really commercialized solution. But in any case, the increased compute ability on these sensors gives them the ability to kind of sift through all of the data that you're getting from your motors and transmit that data less often. Because they're sifting through and filtering out the kind of irrelevant data, they're able to transmit only relevant data significantly less often. And if you're able to transmit less often, you're reducing the amount of battery life that you're using, because things like Bluetooth and Wi-Fi communication is always the most taxing thing on the battery life for these devices. Anytime you're transmitting less, you're utilizing Bluetooth or Wi-Fi less, the battery is going to improve. So Currently, the status quo for the battery is about 2 to 3 years. It obviously depends on how often you're pulling data, but that is increasing pretty rapidly. The last thing is the increasing ability to interrogate data. And this comes back to what I was saying about the data management softwares that are starting to emerge. There is more and more ability to grab a bunch of data and put it into a single central platform. That's becoming, it's making implementing these solutions significantly easier. This is a matrix that kind of gives you a quick picture of exactly what data is being gathered by these sensors. If you look at this, I mean, the first thing that jumps out at you is that vibration and temperature is far and away the most common 2 data points gathered. And that's going to continue to be kind of the standard sensor that's offered. You have other things like acoustic magnetic field runtime, things like that. But those are more application-specific sensors. They're not kind of the general purpose smart sensors that we're seeing. Over time, we expect where smart sensors are installed to change quite a bit. Currently, almost all sensors are advertised as motor sensors. That is where they're being installed as well. So in 2018, we estimated about 84% were installed on motors themselves. As you move more towards 2024, we're expecting a greater number of assets to have sensors developed specifically for them. And this is already starting to happen. ABB released a sensor that is designed for bearing blocks specifically. They partnered with Dodge and produced this, and it's been a very successful product from my understanding. And it's important because bearing blocks tend to be one of the sites of failures most common in motor-driven systems. So that's what we're anticipating having the most connection to in 2024, followed by pumps and gearboxes and the like. Over time, this market is going to move away from being hardware-driven. Currently, almost all of the revenues, or the majority of the revenues, are coming from the purchases of the sensor themselves. But as the hardware cost continues to fall, we anticipate there's going to be more incentive to produce actual solutions like a software as a service model or something like that. So you can see over time, this graph is showing smart sensors and dedicated software and the percentage of share that the two hold. Smart sensors are slowly decreasing because more and more we expect it to be priced on the software itself as opposed to the hardware. There's a greater variety of companies entering this predictive maintenance market and the CMMS system. So this is computer maintenance management software. They're looking to be kind of a one-stop shop, and this is an important distinction in the market because for a long time CMMS has been kind of looked at as like a workforce management platform. More and more they're getting into kind of data standardization services. So I think Fluke has eMate is their CMMS solution, and they actually offer a dedicated service looking to basically standardize and clean your data in order to move away from the piecemeal solution that everybody's used to right now to more of a streamlined, ubiquitous service. And like I said, that's an important feature for moving this market forward as it makes implementing significantly easier. This is going back to talking about why we anticipate portable monitoring devices continuing to grow. A lot of people and a lot of articles I've read have kind of looked at these two products as competitive. I don't think that they are. I obviously said that I believe smart sensors are more of a frontline solution as opposed to the end solution. And portable monitoring devices are more of a complementary device to smart sensors than competitive. The reason being is that they operate at a much higher resolution. And so they're going to be, although you'll need less of them. So when you're talking unit-to-unit basis, you could use one portable monitoring device for 100 smart sensors or whatever it may be. So they're growing a little bit slower, but the two demands are correlated to some extent. There are certain portable monitoring devices that will be displaced. There were some like very simple handheld monitoring devices that operate within the same resolution as a smart sensor, but those are largely being replaced by smart sensors, whereas the more high resolution ones are staying. So yeah, at the end of the day, like it's moving away from being a piecemeal solution and coming under one umbrella. And I can't harp on this enough that this is making this market more easy to enter. This is the last slide, and this is the considerations that I think you should all think about as you move forward with this technology. First and foremost, I don't think that this is an option to get familiar with. I think predictive maintenance is more of an inevitability over time, and that everyone is going to be forced to get more comfortable with this technology. So these are a couple of things to look at and think about whenever you're trying to develop your skills for this stuff. There's going to be an increasing presence of third-party maintenance providers offering remote monitoring PDM services. Some of you may be a part of these companies already, or some of you may be familiar, but a lot of these companies are doing condition monitoring right now. But they're going to move pretty heavily to offering remote monitoring services because it makes sense for their business model. They don't have to go out to your facility every 2 weeks. They can only go whenever you need to. And from a business perspective, this may make sense if you're trying to do predictive maintenance on a basic level. This may be the cost-effective way. So just getting familiar with those models and understanding that this is an option is important for the future. An increasing presence of business models pricing on a factor of uptime as opposed to pricing the whole machine or component outright. I could spend an entire presentation talking about this specific point. This is getting at the new business models that are starting to emerge that are utilizing predictive maintenance as an enabler. Really what I'm talking about here, so there's an example of a company that produces palletizers that has come up with a machine as a service solution. And basically what they've done is they retain ownership of that machine and they give it to the customer and price it on a factor of uptime, meaning that a factor of, I should say a factor of productivity, not uptime. So they're counting how many pallets are being made or whatever the machine is doing. And they've developed a price or an agreement with their customer that prices those pallets. There's an inherent need from the supplier to keep that machine up and running as long as possible because they're still retaining ownership, and as long as it's running and has uptime, they're making money off that machine. That's a model that we've already seen starting to expand. I know of at least 3 companies that are offering that now, where it was just one a little over a year ago. And I expect that to be a model that utilizes predictive maintenance pretty heavily. It's also a model that's used by some component vendors. SKF had a model that was called bearing as a service. And basically what they did was that they developed a method to charge for uptime as opposed to charging for their component outright. Again, this is a very important model to look into going forward as it utilizes predictive maintenance very heavily. I don't need to go over the increased reliance on machine learning algorithms a ton because we've talked about that. But it's going to continue to get more sophisticated, and there's going to be more and more companies using this. So just familiarizing yourself with the tools needed to develop these and understanding that kind of the trade-offs of developing them internally versus using a third party is really important. There is a learning curve for these algorithms if you're developing them internally because you have to go and train these things. Whereas if you're using a third party, you could leverage some of the training that's already been done through other facilities that have used the algorithm. These last 2 points, there's an increasing use of automation equipment to supply greater data resolution via the drive or the PLC. This is an important characteristic, especially early on. If you're looking to get into predictive maintenance early, you would be surprised at how many of your devices that you're already using probably have this feature baked into it. And just figuring out a way to tap into that is really important. The drive itself can be used as a sensor. It basically is a sensor in that it automatically is taking information on the electrical behavior of the motor. And it can read basically when the motor is demanding more and more energy. And that can be an indication for the motor being under stress or something like that. I know Danfoss, I forget the exact model, but they produce a drive that's both a sensor and a place to aggregate data. And that's probably the more sophisticated solution that I've seen in the market So it's taking smart sensor data or anything that you could offer it via Bluetooth, and it's also reading the electrical behavior of the motor. And at the end of the day, the more data that you have to feed a machine learning algorithm, the more accurate it becomes over time. And then this last piece, we expect there to be an eventual integration of sensing into components like motors, fans, gearboxes, compressors in the future. I mean, I don't think it's any secret why some of the early movers on supplying this technology have been the big motor manufacturers: ABB, Siemens, WEG, Nidec has its own sensor as well. All of these, it points to their thinking that there is going to be integration of these sensing into their core businesses at some point. It's something to think about. I don't have a ton to say about it because I think it's a trend that's going to happen far beyond this report, the forecast of this report, that is, but something to consider. And with that, I mean, I hope this has been informative and given you some context into where I think these trends are going and what to expect in the future. I'm going to pass the mic back over to Kevin, and I'm ready for the Q&A.
Well, thanks, Blake. There's no question that the presentation you delivered to us today did provide the context that you spoke of at the beginning, and we thank you for it. We look forward to seeing you in the live Q&A immediately following. Be sure and have your questions ready. Thanks for joining us, and we hope the information provided will suit your purposes.